In this video, you will master Kubernetes role-based access control. Given a grade submission API exposing GET and POST endpoints, we're going to implement access control to ensure that only authorized clients can actually access these resources. We're going to set up a secure validation endpoint that essentially acts as a gatekeeper, which itself requires specific roles and permissions in order to validate clients against the Kubernetes API. So this multi-layered RBAC implementation will give you hands-on experience with service accounts, cluster roles, cluster role bindings, verbs, and API groups, everything you need to fully master Kubernetes access control. So let's dive right in. All right, let's begin. So this repository contains the starter code that you need for this tutorial. I left you a link to it inside the video description. Make sure that you go to it and then copy the necessary URL that we're going to need in order to clone this repository into a directory of your choice. I'm going to clone it inside of my downloads folder for ease of access. All right. Then from my downloads folder, I'll go ahead and drag the starter code into Visual Studio Code. You can use whatever editor you want, doesn't really matter. Looking at the starter code, we have a namespace called grade demo. This namespace grade demo is going to harbor the deployment of a grade submission API, which we're going to use to submit and retrieve grades from it. And we also have a node port service that provides external access to the grade submission API on our nodes port 31,000. All right. Now, if you took my Kubernetes course, you'll know that the grade submission API provides access to many endpoints. For the sake of this tutorial, we're going to just assume the existence of GET and POST operations. So let's go ahead and just apply these resources for now. Apply everything, every single file that defines resources inside of the current folder. All right. And now I want to check the pods that are running inside of the grade demo namespace. Make sure everything is good. All right. Let's go ahead and make some API calls to the grade submission API to get started. So inside of the repositories is README, I left you with commands that you can use to add grades to the grade submission API. If you're using a Mac, you can freely copy these into your terminal. If you're a Windows user, use git bash in order to be able to use those same commands. If you insist on using something like PowerShell or command prompt, then you'll have to adjust these commands accordingly. So I'm going to go ahead and copy those in, make some post requests. Everything works beautifully. We submitted 3 grades, one for Harry, one for Ron, one for Hermione. Now let's test making a GET request to retrieve those same grades. That works as well. Everything worked very, very smoothly, and therein lies the problem. The client was able to very freely, without restriction, access the post and the GET resources that are provided by the grade submission API. It didn't have to go through any security checkpoints that ensure the client has the necessary authority to actually access these resources. And that's a problem. What we need to do is implement access control to ensure that whatever client is trying to access these resources is actually authorized to do so. So what we need to do is set up a secure validation endpoint, a secure proxy that stands in front of the grade submission API and acts as a gatekeeper, which will ensure that whatever incoming requests are coming in to access the grade submission API's resources, they have the necessary roles and permissions that would authorize them to do so. Let's go ahead and implement it right now. Inside of the grade submission API pod, we're going to create another container, a sidecar container. And that sidecar container, I'm going to call kube-rbac-proxy. If you took my Kubernetes course, if you haven't, highly recommend you do. Link is in the description. You'll remember that a pod can have many, many containers, usually one container which serves the core functionality of the cloud native app of the microservice, and sidecar containers that enhance the functionality of the main one. How does the kube-rbac-proxy container, how is it going to enhance the functionality of the Great Submission API? Well, in this case, what it's going to do is implement access control on any incoming requests that come in and ensure that they're actually authorized to access whatever resources are in the Great Submission API. This container I'm going to create based on the image, which I will leave you inside of this video's description. Go there and copy it down right over here. And as this container is created, it's going to harbor a kube-rbac-proxy application, which will serve as a secure endpoint to validate any incoming requests that come in before they reach the API. Now, how do we configure this container's underlying application to actually secure all our requests? Well, this is where I would love to refer you to documentation. So if you go to the GitHub repo, which you can access by simply Googling it, looking at the README, we see a definition that kind of validates what we've been talking about so far. So if a request is made to this proxy, what it's going to do is perform access control against those requests by verifying them against the Kubernetes API. And if those requests are valid, it's going to send them upstream to whatever resource they're trying to access. Okay, now going back to the question, how do we configure the kube-rbac-proxy container to effectively validate all the requests that are going into it? I left you a link that allows you to access an example of how the kube-rbac-proxy container can be configured. Make sure to click on the link and copy this down. All right. So what these are command line arguments. This we don't need. Upon requests being validated, they will be sent upstream to the same local pod, but on the container port 3000 towards the API. Logging, we can leave, that's fine. All right, so what's happening here? As containers are created, some of them require arguments to be passed into the command line in order to steer the creation of that container towards one that works for you. If you are creating that container using Docker commands, this is how it would look. But because we're using Kubernetes YAML, we specify the command line arguments as follows, okay? Let me just fix the indentation. And what these arguments do, well, you know what? Let me just refer you to the documentation. So here are a bunch of command line arguments that the underlying kube-rbac-proxy application expects. One of them is insecure listen address, which sets up an HTTP server. One is secure listen address that sets up a secure HTTPS server, therefore allowing HTTPS requests to be made to the kube-rbac-proxy app. Essentially, we get TLS encryption, which is always good. And anyways, upon the request being sent to this HTTPS server, what it's going to do is validate and check if that request actually is actually authorized to access whatever resources are in the Great Submission API. If they are authorized, what it's going to do is it's going to send that request upstream to its local host, 127.0.1. So local host in this case is the pod that it's local to. And within the same host, it's going to send that request upstream to the container port 3000 to the Great Submission API, which is then essentially going to process the request and send back a response. Now, if upon the HTTPS server receiving that request, if it doesn't validate the credentials, if it deems that they're not authorized to access the API, it's going to reject that request. And whether the request is acknowledged or rejected, that's going to be logged to standard error with a certain level of verbosity, okay? So nothing very hard over here. This is just a way to set up command line arguments using Kubernetes. In any case, this container is going to run on container port 8443, and here all they did was they gave the container a name, HTTPS. All right, and now we need to modify this service. So this service points directly to our container port 3000 of the Great Submission API. Instead, what we wanted to do is point to container port 8443. All right, you know what? Just to vary things up, why don't we refer to the container port name. So this will be the exact same thing, all right? When a request is made on localhost 31,000 of our nodes' port, that request is going to be redirected to the Great Submission API pod on the target port 8443, where it's going to validate the request, see if it's actually authorized, and send it upstream to the Great Submission API's as port 3000, all right? Will this actually work? Let's try it out. So I'm going to clear the output. I'm going to say kubectl apply -f, applying everything here. The deployment gets configured. And now what I'm going to do is say kubectl get pods -n grade demo, just to make sure everything's good. All right. So now we have a Great Submission API pod that has two containers running in it. The main Great Submission API and a Sidecar container that is going to validate any requests that go to it. All right, so now if I try to make the same request as before, first it's going to tell me you can't send an HTTP request to an HTTPS server. So what we need to do is say HTTPS. Now, when making HTTPS requests, two things happen: TLS encryption and certificate verification. TLS encryption is going to happen behind the scenes automatically, but certificate verification, we don't really need to deal with. So we'll say -K to skip it. And we get an unauthorized message. Beautiful. That's exactly what we wanted. How are we going to give this client the access, the roles, the permissions that it needs in order to be authorized to access the API's resources? Well, before we do that, let me say kubectl logs-f. Let's view the logs being outputted by the Great Submission API pod, but specifically for the container that is named kube-rbac-proxy. All right, and then we specify the namespace grade demo. Nothing interesting here. It's generating a self-signed cert, which is fine because we're skipping certificate verification anyway, and it's listening securely on port 8443, and it did not authorize us to make whatever request that we needed to make. All right. Beautiful. So now let's go ahead and give this client the roles and permissions that it needs. So let's go ahead and stop the output. And what we need to do is somehow give this command line, this client, the permissions that it needs in order to be able to access the resources provided by the Great Submission API, okay? Whatever endpoints the Great Submission API provides. And any access control resources we're going to define instead of O3 rbac.yaml, okay? Now, if you took my Kubernetes course, you'll know I have the Kubernetes extension enabled, and usually that allows me to autocomplete many different types of Kubernetes objects, stateful sets, secrets, etc. But for service accounts, which I'll explain what that is in just a second, I don't have that option. If you have a fix for that, let me know in the comments section. But anyway, let's go ahead and just write it out from scratch. We start with the typical API version, v1, kind is a service account. Then we go to the metadata, name, we'll call the service account grade service account. I'll explain everything I'm doing in just a second. We'll deploy the service account inside of the same namespace as everything else. And that's all you need to define for a service account. Why? All a service account is a badge that something can use to identify itself within the Kubernetes ecosystem. To give you an analogy, I work for the federal government. If I just go to the security guard and say, hey, I'm Ryan Slim, he'll just promptly escort me out. If I present the security guard with a badge that clearly identifies my role within the federal government, then he'll allow me to go in. Similarly, our client here, the command line, tried waltzing in to the Great Submission API and access its resources, but the kube-rbac-proxy, in this case a security guard, stopped it in its tracks and said, hey, do you have a badge? What's your role here? So what we're going to do is associate our client, the command line in this case, with a badge that it can use to identify itself. Now this begs the question. Now that we created a service account, we somehow need to assign this identity to our client. And the way to do this is to, extract a token out of the service account, and that's usually done using secrets. So we'll go ahead and create a secret right now, o4 secret.yaml. This I can autocomplete. The secret I am going to call grade SA token, because ultimately we're going to use it to extract a token out of the grade service account. The secret type in this case will not be opaque. It will be a special secret type, Kubernetes kubernetes.io/service account token. I'll explain the secret type in just a second, but let me go ahead and remove the following. And this secret I want to deploy inside the same namespace as everything else. And now I need to associate this secret with the following service account. And the way to do that is to create an annotation called kubernetes.io/service account.name. And we associate it with the service account name, grade service account. All right, not an equal sign. What am I doing? Now let me just make sure. All right, everything seems good. We'll go with that. So what did I just do? If you have a secret with type kubernetes.io/service account token, that secret will automatically have a data.token field. Remember that. And that field is going to get populated by Kubernetes with a token. So that's why you can extract a token out of this secret, and the client can use that token as a way to present their badge. So given this configuration, the token extracted from the secret establishes the client's identity as that service account. So let's go ahead and extract a token out of this secret. The way to do this is, let me clear the output so we're not writing commands at the bottom of the screen. So we'll start by applying all of these resources. kubectl apply -f, apply everything inside of the current folder. Secret gets created, and its course service account and secret get created. Now I'm going to say kubectl get secret grade service account token. That's inside of the namespace grade demo. And I want to output its YAML, because now Kubernetes auto-generated some fields in it that I want to view. And the field I'm interested in is the following token. The client can use this token as a way to present their badge, as a way to establish their identity as that service account. But this token is base64 encoded, so we need to base64 decode it. So let me clear the output. And instead of presenting what we just had as YAML, let's present it as JSON. And now you can see that under .data.token, we can extract the following token using the JSON path tool. So what I'm about to do now, Windows users, make sure that you're using git bash, otherwise your command isn't going to work. So kubectl get secret-o, and now I'm going to use the the JSON path tool, because I don't want to output the whole JSON, just one field in the path. You'll remember it started with .data, that was the first field, followed by .token. So extracting this, do we get, yep, what have I done? Oh, exit. What am I doing? Oh, this should be a double quote, my bad. So it effectively extracts the token, but this is base64 encoded. We need to base64 decode it into plain text. So the output that we get out from this command, we can pipe it. So Windows users use git bash here, please. We can pipe it into another command that will base64 decode it. All right. And here is the token that our client can use to establish its identity as the service account. How is it going to do that? I left you a handy command inside of the README. And instead of token here, so inside of the request, we add a header, the typical authorization bearer token. Let's just go ahead and copy it like so. There's a cleaner way to do this. I'll show you in just a second. And we get unauthorized. And this I expected because our service account isn't associated with any roles. So while we did provide our identity, we didn't really tell it what our role within the Kubernetes ecosystem is, and therefore I expect that it would deny us permission. So if I clear the output, there are many built-in roles that are automatically established within Kubernetes. If I say kubectl get cluster role within the default namespace, we can see many roles. The most common ones are cluster admin. So if someone has this role, they basically have full access to all resources across the cluster. They can perform any action on any resource on any namespace. The admin role is pretty much the same thing. You get full access to all resources, but within a particular namespace. The edit role can modify most resources in a namespace. And another very popular one that is used is the view role, which is only given read-only access to most resources in a namespace. So what we're going to do to keep things simple is to just give our client its associated service account the cluster admin role, being able to do anything it wants, just so that we can get that request working to start, and then we'll go ahead and follow best practices afterwards. So what I want to do is, I'm tired of writing things from scratch. I left you a link to this section within the documentation. Copy down this cluster role binding example right over here. Because what we're going to do is bind this service account to the cluster admin cluster role. Okay? And how are we going to do this? First, let's remove this useless comment. I'm going to name the following cluster role binding grade submission binding. Okay? Subjects defines who gets the permissions. In this case, the type of identity is a service account. And the name of the service account that is getting the permissions is called grade SA. And here, instead of a name, I'm going to say name. And here, we need to specify the namespace grade demo where the service account is in, so that the cluster role binding can accurately find the grade service account and associate it to the cluster role cluster admin. So we basically just gave whoever is associated with the service account full access to do whatever the heck it wants on the cluster, let alone just accessing a few trivial resources in the Great Submission API. Will this work? Let's find out. So I'm going to clear the output. I'm going to say kubectl delete. Delete any resources that might have been created from this file. Service account gets deleted. I might have already had the cluster role binding there before starting this tutorial, so it gets deleted for me as well, but for you, it should show error, can't see a cluster role binding. And by virtue of deleting the service account, its associated secret will get deleted as well. So if I say kubectl get secret grade SA token -n grade demo, it's gone. Beautiful. Virtue of it being connected to that service account. Okay, now let's go ahead and apply everything. kubectl apply -f everything inside of this current folder. Same as before, we're going to extract the token from the secret. Good to have this command handy. Now if I say curl, you know what? Let's copy the following command. What the heck? Replace token with the following token. I'll show you a way to streamline this process in just a second, but for now, I want you to have a clear visual of the token. You could use variables, but anyways, we still get unauthorized. Why? We clearly gave this service account, our client in this case, access to do whatever the heck it wants. It's a cluster admin. It's a super user. The reason it doesn't work is because we need to debug and troubleshoot what the heck is going on. When troubleshooting, don't panic. Whatever Kubernetes resource is, in your opinion, malfunctioning, describe it. Look at its logs, what's going on. So in this case, the kube-rbac-proxy isn't allowing my client access to the grade submission API. And I need to figure out why. So I'm going to say kubectl get pods -n grade demo. Make sure all the pods are running properly. The pod is running properly with both of its containers healthy. I'm going to say kubectl logs -f. Try to extract the logs from this pod for the specific container kube-rbac-proxy. Why isn't it able to authenticate me? And therein lies the problem. We get forbidden messages. Whenever you get messages like forbidden or unauthorized, chances are there is something that is trying to access something else but doesn't have the correct permissions. In this case, the kube-rbac-proxy is trying to validate our token. In order to do so, it needs to reach out to the Kubernetes API server in order to create a resource of type TokenReviews. But the Kubernetes API is forbidding it from doing so, and therefore not allowing the kube-rbac-proxy to do its job to validate our token. So how do we give the kube-rbac-proxy the permissions to create token reviews? We need to assign it a service account that is bound to permissions that are sufficient for it to be able to create these token reviews. So what I'm going to do is create another file called RBAC-proxy. Here I'm going to define the role-based access control resources that our kube-rbac-proxy needs in order to be able to create token reviews. Now I'm going to pretty much copy all of this for now. Just give it cluster admin access so that it can do whatever it wants. But now what I need to do is rename this to something like grade proxy. Okay, so it needs to use a different service account. And the cluster role binding, I'm going to call grade submission, proxy binding. We define a different cluster role binding for this other service account. And it will also have cluster admin access. All right. And now what we can do under spec, we can specify a service account name of grade proxy right before containers. So now effectively, when the kube-rbac-proxy tries reaching out to the Kubernetes API to try to create these token reviews, it will be given access. So currently it's using some default service account that gets auto-generated, which doesn't have the permissions to do token reviews, but now we gave it a service account that has cluster admin access and should have the correct permissions to do whatever the heck it wants. So now our flow should work. Let's go ahead and delete whatever resources were created from o3rbac.yaml and start fresh. What am I doing? kubectl delete -f. Okay. And go ahead and reapply everything. All right. Now I'm going to make the request again. Extracting the new token, copying that, and using that in our curl command. Let me just copy the following. I'll show you how to use this variable in just a second. Beautiful. We get back an empty list. Now, you should have gotten the grades we submitted before Harry, Hermione, and whatever, but I stopped this recording midway and had to delete everything for other reasons, reset the cluster. But anyway, we can go ahead and repopulate our app with some data. I'm going to do it right now. Along the way, I'll teach you how to use these variables. So what we can do is, instead of always extracting the token like so, we can say, let me go all the way back. Again, Windows users, make sure to use git bash if you want this to work. Otherwise, adjust the command accordingly. Export token. I'm going to get a variable that equals whatever output comes from the following command. I always hate this part. Come on. Then what I can do is just say, literally just copy the command from here. Beautiful. And now I can go ahead and use all of these commands. All right, we're able to submit data. And we can retrieve that same data. So what's ultimately happening? Let's describe the flow. First, our client is making a request to the grade submission API and using this token to identify themselves as a service account that has cluster admin access. And following that, the kube-rbac-proxy gets the request, takes the token, and validates it by creating a token review object, which allows it to check what roles and permissions that token has. It sees that it's associated with a service account that is a cluster admin and therefore allows our client access to the grade submission API. In turn, in order to create the token reviews, the kube-rbac-proxy itself needed special permissions in order to do so, and we gave it cluster admin access. Now, we don't want to just give everything in our Kubernetes cluster admin access, because ultimately that defeats the purpose of role-based access control. In that case, you might as well not even implement it. You need to give each component just the exact permissions that it needs in order to access whatever it is that we need to access. We shouldn't allow the kube-rbac-proxy to be able to have full access to all resources across the cluster. We shouldn't allow anybody making requests from the command line to just have full access to all resources across the entire cluster. So let's go ahead and fix that right now. What I want to do first is start by doing a hard reset. So kubectl, I want to delete every single file or every single resource that was created from these files in the current folder. everything was deleted. Let me make sure. kubectl get pods -n grade demo. Pods are still terminating. I'll give that time to delete. Anyways, while all of this is deleting, what I want to do is revoke the service account that gives the kube-rbac-proxy cluster-wide access to everything. We just want to give it the permissions that it needs in order to access that token review resource. Before we go ahead and do that, let me make sure that everything was deleted. Are the pods still terminating? Get pods -n grade demo. Okay, cool. I'm going to remove or comment out this cluster role binding. I'm going to give this another name just to ensure we're not using any orphaned resources by any chance. So I'm going to call this grade service proxy. Do the same thing here. I'm going to call this grade service account. Change the naming here as well. Need to change it here as well so that the secret, I must have already done this before starting the video. The secret needs to be associated with this service account. Okay. And reapply everything. kubectl apply -f everything. All right. Let's extract the token from this secret. The command is somewhere towards the end. There it is. And there's a curl command that you know what, I'm just going to grab it from the README right over here that I can use. I'm going to get unauthorized. Perfect. That's exactly what I wanted. Let's say kubectl get pods -n grade demo. Get the logs for this particular pod. -n grade demo for the container named kube-rbac-proxy. Okay. And so here is the information I wanted. The resource that it specifically can't access and the API group that this resource is in. Why do I need this? Well, here, what I want to do is define my own custom cluster role that tells Kubernetes what resources this service account has access to, what it's allowed to do to these resources, in this case, create, and what API group this resource is in. So let me just take a mental note of all this right now. We want whoever is identified by this service account to be able to create, that's the verb, certain resources. Those resources that it needs to create are specifically TokenReviews, and that resource belongs to the API group authentication.k8s.io. Okay, so let's go ahead and try to implement this now. I left you a link to this section of the documentation within your within your video description. So make sure to go to this piece of the documentation, click on the link. Here we can define our own cluster role. Okay, so the cluster role I'm going to call, in this case, grade service proxy role. Okay, and here we define the rules, basically define what permissions the service account will have. API groups is interesting. API groups are a way to organize related Kubernetes objects and resources. So each group contains resources that are, logically connected. So by specifying an empty group, this is the core API group. And resources that belong to this group are pods, secrets, services. Okay, so if we specifically want to provide our service account access to pods, secrets, and services, and allow the service account to be able to get, watch, or list them, then that's the cluster role that we would have. Another popular API group, or common API group, I should say, is apps. And this groups resources such as deployments and stateful sets. So if you wanted your service account or whoever is associated with it to be able to perform these actions, could be get, watch, list, create, whatever you want on these resources, then this is the cluster role you would want to create. In this case, what we want to do is be able to give our service account the permissions to create token reviews. This is a custom resource, not your typical core resources like services and whatever. And the API group that this belongs to is authentication.k8.io, because we literally just extracted it, right? Now, if you were ever unsure what exact verbs, what exact operations you want your service account to be able to do on these resources, then you could simply give it every single possible action by specifying the star. Okay, but I know specifically that all we need to do is create this resource, so I'm just going to say create. If you're not sure what API group your resource is in, you can simply specify star and tell it to look inside of every API group. Now, let's get rid of these comments. If for whatever reason you put a star everywhere, then you're basically saying, look, this can perform any action across any resource, across any API group. You're basically giving it cluster admin access, right? But we don't want to do that. We want to be specific as to what permissions we want to give it. All right. And that's pretty much it. We just defined a cluster role. And now what we need to do is bind whoever has this service account to this particular role. And the way we do that is we specify the service account and we bind it to this role that we just created ourselves. We're not going to give it cluster admin access. We're going to give it grade service proxy role access, the ability to create token reviews in order to validate whatever tokens come from the client, okay? We'll change this in a bit, but let's test what we have so far. So, oh, not to forget, we give this a service account of grade service proxy. By the way, if you specify a service account name and that service account doesn't exist, you're not going to see any pods get created because the deployment is going to be confused about what you're trying to do. So always make sure that you specify the correct service account name. And if you don't have a service account, make sure that you remove this field or your pods will never begin. Initiate or whatever the word is. All right, I'm pretty sure we're good. Let me just ensure everything is done correctly. All right. I'm going to delete everything and start again from a clean slate. This should take a minute for the namespace to get fully deleted. You know, the pods in it are still terminating, so I'll be back in a second. Feel free to pause the video. All right, let's check again. Everything's been deleted. Cool. Make sure that you do not proceed until you ensure all the pods are gone. That way we can just apply everything all over again with our new permissions given to the kube-rbac-proxy. And then get that token again from our secret. All right, and we can go ahead and try this out. Fingers crossed. And why are we getting another error? Are we really all done? Let's find out. Again, never panic, look at the logs. First and foremost, does the secret exist? kubectl get secret-n grade demo. It does. Okay, so we were able to get a token out of the secret, and obviously the client was able to have cluster admin access. So clearly not an issue with the client, which means we still have an issue with the kube-rbac-proxy. Why isn't it able to validate our token? kubectl get pods-n grade demo. Everything is working fine, but let's look at the logs. Again, never panic, just look at the logs. Grade demo for the specific container kube-rbac-proxy. All right, and we seem to come across another issue. The kube-rbac-proxy, in order to validate the token, not only did it need to create token reviews, but it's also trying to create these things called subject access reviews, right? But it's being forbidden from doing so. So here the verb is create. The action it's trying to do is create. It's trying to perform this action on a resource called subject access reviews that belongs to the API group authorization.k8s.io, which means I can just put a comma here under this array, give it the same access to subject access reviews. Actually, I take it back. This falls under the API group authorization.k8s.io, not authentication.k8s.io. So if you write that, it's going to look for a resource inside of this API group called subject access reviews. It's not going to be able to find it. So we could just put an asterisk here and say, look for these resources across all the API groups, but it would be better practice to just create another rule, okay? Where here, it looks for the subject access reviews within authorization.k8s.io. And here, a rule for creating token reviews within authentication.k8s.io. All right, so let's go ahead and reapply this. So kubectl apply-f, clear the output, and grab the token, make a curl command, we get an empty list. Wonderful. All right, so one last step. I promise you no more tricks. So now this service account has cluster-wide access to everything in our cluster, which is bad. If someone gets a hold of the service account token, let's say some bad actor, they would have the permission to do whatever the heck they want on the entire cluster. We can only give it the permissions that it needs to access the URLs provided by the Great Submission API. So that's a URL to make GET requests and a URL to make POST requests. Now, this is a bit tricky because these aren't your standard Kubernetes resources like pods, services, stateful sets, or secrets, or in this case, custom resources like TokenReviews, SubjectAccessReviews. These are URLs present in a microservice. And there is a way to provide access only to those, and that is through, so here by looking at the documentation, you can see, again, API groups apps, the deployment files under that API group. Here are verbs that allow whatever service account to do whatever they want to deployments. Anyway, I digress. What I want to do is look for an example where we can modify non-resource-URLs, and this happens to have exactly what I need, okay? So rbac.yaml, let me go ahead and create a cluster role right over here. I'm going to call this cluster role grade service account role, okay? I'm copying this, the rules, what we're going to allow it to access. Let's allow it to access any URL provided by the Great Submission API, okay? I know we've only been accessing /grades, so technically we should just put /grades here. But there are actually many API endpoints provided by the API. I've just neglected to mention them because they're not relevant for this tutorial, okay? So allow it to access any URL, and we already have our verbs set up for us. And as you can see, the verbs depend on what resource you're operating on. So for a Kubernetes specific resource, like, I don't know, a service or a secret, you can create secrets, you can delete secrets, you can update secrets, and the verbs reflect that. For URLs, what you can do is make GET requests and POST requests, put requests, so the verbs would reflect that as well. For a complete exhaustive list, go on the documentation, depending on what it is that you're trying to do. But anyways, we have our grade service. This should be called grade service role. My bad, guys. We have our grade service role. We need to bind this role to our grade service account. So over here, under grade submission binding, Instead of binding it to a cluster admin role, giving it cluster-wide access, we'll bind it to a grade service role, okay? So now let's go ahead and say kubectl apply-f apply everything. Oh, cannot change role ref. In this case, what I want to do is say kubectl delete-f03, all the resources created from here. Reapply them. Beautiful. The secret gets recreated. Let's go ahead, fingers crossed, get the token from this secret, make another curl command. Beautiful. This concludes our tutorial on role-based access control. You were able to learn about so many different components like service accounts, cluster roles, cluster role bindings, actions that can be performed on specific resources that you want to allow certain components access to. And you learned all this through a very multi-layered example. I guarantee you, as of this recording, this is the only resource online that will teach you about role-based access control to such depth. And if you want to really master Kubernetes and gain access to very comprehensive content, highly recommend checking out our Kubernetes Bootcamp, Conquer Kubernetes from Zero to Cloud. I promise you, you won't regret it. And if this is your first time watching this channel, highly recommend subscribing for more DevOps content, and I will see you in the next one.